I will start the presentation. My name is Lee Soo-hyun. From now on, I will present the theme of improving the performance of the solder-based oxide TFT development and annealing process using metal font. This is our content. First, I will introduce our motivation. LTPS TFTs are widely utilized for high-resolution displays. However, LTPS TFT requires high process temperature, and it can be achieved by complicated vacuum process. Therefore, we need alternative processes and materials for next-generation functional displays. For this, metal oxide-based TFTs, which are realized by a solution process with low fabrication cost and simple process procedures, can be used for flexible displays. But actually, this simple process requires high temperature of about 500 Celsius degrees. So reducing process temperature is the key to realize flexible display. Let's talk about material. IGGO has high mobility even at amorphous phase compared with silicon, better uniformity than LTPS, and optical transparency. Owing to these advantages, it has been applied in many devices as shown here. Next, I will introduce the solution process used in the experiment. Currently, oxide semiconductor-based thin films are manufactured using vacuum process equipment that can control the process environment. However, vacuum processing equipment requires very expensive vacuum equipment and has the disadvantage of difficulty in forming a large real thin film. Therefore, the experiment was conducted using a solution process that has a relatively low process cost and can mass produce a large area. Particularly, the solution process has the advantage of being able to control the characteristics of the oxide semiconductor thin film through a relatively simple and effective composition ratio control or doping process. Now I will present the fabrication process. This is the order of production to make IGGO TFT doped with tin. First, prepare a solution mixed with IGGO and tin, and clean the wafer in order using acetone, IPA, and DI water. Next, ultraviolet ozone treatment is performed to make the surface of the substrate hydrophilic, and spin coating is performed using IgG solution to deposit the thin film. And heat treatment is performed at 400 Celsius degree for an hour to form a metal oxide bond in the thin film. And with the beam evaporator, an aluminum thin film to be used as a source and drain electrode is deposited. Finally, measure the properties of the thin film. Next, I will present the mechanism. The following equations show that oxygen vacancies and electrons are formed as tin is replaced by the zinc lattice in IGGO. When tin is properly doped, the oxygen vacancy and electrons increase, improving electrical conductivity and mobility. If tin is excessively doped, tin is oversaturated in IGGO, resulting in lower mobility and optical transmissions. Next, I will present the differences according to the annealing temperature. If the annealing temperature is 300 Celsius degrees, the roughness of the IgG thin film increases, resulting in many defects in the interface between the channel port and the source drain electrode. Therefore, the homogeneity of the thin film is reduced. On the other hand, if the annealing temperature is 400 Celsius degrees, the roughness of the IgG thin film decreases, reducing the interface between the channel port and the source drain electrode. Therefore, the homogeneity of the thin film is optimized. In conclusion, in order to minimize defect, it was found to be more appropriate when the annealing temperature was 400 Celsius degrees. Next, I will show you the results of the experiment. We manufactured IgG-TFT based on solution process. A and B graphs in the following data show the transfer curve and gate current characteristics of IgG thin film transistor based on a SiO2 insulating film manufactured using a solution process. In addition, looking for the figures below, A is the process of the SiO2 insulating film-based IgG thin film transistor. B is the AFM image of IgGO, and C is the XRD result. As a result of analyzing the electrical characteristics of the IgG thin film transistor, it was confirmed that it has enough current ratio and stable leakage current characteristics within the 5-volt range. In particular, it was judged that it was high utilization value as a driving device of a high-quality display backplane, draw of current to 10 to the power of -10 ampere or less, and threshold voltage characteristics of -2 volt. The following is the graph of IgG thin film transistors based on solution processes using tin doping. The A graph is a transfer curve of the IgG thin film transistor to which 0.1% of metal additive is added, and B is 0.5%. In the zinc lattice of IgGO was replaced with other metal ions to increase oxygen vacancy and electrons of a thin film transistor to induce mobility improvement. But of current was greatly increased and threshold voltage was moved. And to solve this problem, various experiments were conducted, such as adding pre-annealing. The next is a graph showing the results of tin doping. It is a graph doped with tin of 0%, 5%, 10%, and in comparison, IgG-TFT manufactured by 5% tin doping had a higher enough current ratio and linear mobility than when 0% and 10%. In other words, 5% tin doping has the best IgG-TFT performance. The following is a graph showing the results according to the process temperature. This graph shows the case of heat treatment at 300, 400, 500 Celsius degrees when tin is 5%. First, comparing the two results, it can be seen that the homogeneity of thin films decreased due to the formation of windows, by defect at low temperatures. Comparing the other two results, it was confirmed that off-current increased as polycrystalline of some regions was formed in the amorphous phase at the high temperature. To summarize the presentations, first, IgGO could be manufactured using a solution process and a thermal annealing, and its performance could also be improved. Second, by doping tin, an IgGO thin film with a better on-off ratio and mobility could be produced, and it was found that doping at 5% showed the best performance. Likewise, an IgGO characteristics show the highest performance when the thermal annealing is 400 Celsius degrees. Lastly, during the thermal annealing, an IgGO thin film in which the generation of oxygen vacancy was suppressed could be obtained because metal oxide bound in the thin film could be formed by high heat energy. The references are as follows. That's it for the presentation. Thank you.